Hello, I wanted to make a video on some of the review problems so that you guys got some help and kind of just a little bit of a review on the different kinds of questions you might see on this upcoming test. So if you go to the first page, number 1, all right, it asks you to multiply these. So you need to multiply the bases, which gives us a 12. And then when we do a to the power of 2 times a to the power of 6, we have to use that multiplication property where we add them. So it would be a to the power of 2 plus 6, which is going to give us a to the 8th. So that would be our answer for number 1. Now I'm going to go ahead and try number 14 because I figured you guys would have a lot of questions on this one. So if you notice, first off, in the numerator, all of these guys are being multiplied, right? And since they're being multiplied, we can go ahead and distribute that 2 to each of these. If there was a plus or a minus in there, plus or minus sign, we wouldn't be able to do this. But since it's all being multiplied, we are allowed to do this. So when we do that, we get 144 times. Now we have to use, so here I guess I should show how I did that. I did 12 squared, which gives me 144. And now we have to use our power rules. All right, with exponents, our rule of powers is that when you raise a power to a power, you multiply it. So you would get x 2 times 2 and y 6 times 2. So when you raise a power to a power, you multiply. So you would get x to the 4th and y to the 12th. All over 8 x to the 4th, y to the 7th. So now we have to go ahead and simplify this. So these guys, I'm going to see if I can reduce this fraction. And I can. 144 divided by 8 gives me 18. And then we're going to go ahead and use the division property, the quotient rule, right? So the quotient rule states that we can take these powers when we're dividing them and we subtract them. So we end up with x to the 4 minus 4 and y to the 12 minus 7. So x to the 4 minus 4 gives us x to the 0. Oops. And then we get y to the 5th here. Now we don't write x to the 0, so it just ends up being 18 y to the 5th. So that is how you would go about some of these exponent property ones. All right, so now for a through I, they're asking you to write these as powers and reduce if possible. All right. So I'll go ahead, I will do, let's do G. All right, so we're going to write these as powers and then see if we can reduce them. So one thing I want to point out, and you might want to write this down, this is always equal to x to b over a. All right, you take this guy, he becomes the denominator, this guy becomes the numerator. All right, so we end up with 40, and notice how this doesn't have a power, so it would just be to the 1/3. The x becomes 8 to 8 over 3, and the v becomes 12 over 3. Now you can reduce the v, so you can keep this as 40 to the 1/3, x to the 8/3, and then this is going to become v to the 4th. Because 12 divided by 3 is 4. So that would be our answer there. All right, so for these kinds of problems, these are both under the cube root. So we could actually write them like this. Oops. All right, so we end up with cube root of 27. Which we should know the cube root of 27 is 3. All right, so let's go ahead. The next page asks you to evaluate each expression. So we're going to go ahead and use our log properties. We've got division, right? And if you recall, log of a over b is going to give us log of a minus log of b. So that's what we're going to do. We're going to do log base 7 of 1 minus log base 7 of 343. All right, now log base 7 of 1, so you have to kind of think of it as, okay, if I've got log 7, 1, And I want to know what this equals, right? Well, 7 to the power of what gives me 1? That's going to be 0. Then for this guy, we've got log base 7 of 343. All right, we need to figure out what this equals. We get 7 to the power of what gives you 343. Well, that's going to be 3. So our answer here would be -3. All right. So now let's go ahead. We have graphing. So let's kind of go over graphing here. So just to reiterate, the parent function would have the asymptote here. All right. The parent function for this graph would be log 6 of x. All right. And so for all logarithms that aren't transformed, the asymptote goes through the y-axis. So the asymptote here would be x equals 0 to begin with, okay? So now we know that all logarithmic graphs go through that 1, 0 before the transformation, right? And then this guy is a base 6, so he would be 6, 1. All right, so now we need to go through and transform these points. So this 1, right, when the one that's inside with the x, it does the opposite. So if it's a -1, we're actually going to go up +1. So we're going to go 1 to the right and 5 down. So I'm going to go 1 to the right, 1, 2, 3, 4, 5 down. All right, 1 to the right, 1, 2, 3, 4, 5 down. All right. Now I moved, right? I went to the right. So now I also need to move my asymptote, right? My asymptote's got to go to the right. So that's going to be my new asymptote. So that would be my new graph. Now, in terms of the domain, so the domain has to do with that asymptote, right? So my domain here is going to be open, 1 to infinity. All right. My range is going to be -infinity to +infinity. For these log graphs, the range is always -infinity to +infinity because you can get any y value. All right, next one. So it says condense each expression to a single logarithm. All right, so let's go ahead and try this one. We've got log base 2 of 5, log base 2 of 6 over 2, and log base 2 of 11 over 2. So this is the same thing. Dividing by 2 is the same thing as being multiplied by 1/2, right? So we have log base 2 of 6, 1/2 log base 2 of 11, and then of course we have our log base 2 of 5. All right, so I want to move our 1/2 up here. So we get log base 2 of 5 plus log base 2 of 6 to the 1/2 plus log base 2 of 11 to the 1/2. Now, you can write these as powers, right? So you could condense this, I'm sorry, not as powers, as roots. So this is going to become log base 2 of 5 times root 6 times root 11. That would be your answer there. You also could get, I would be happy with this answer, if you got 5 root 66, because technically you could combine those guys. All right, then we've got expand each logarithm. So let's go ahead and look here. Notice how we have this 4 out in front. So both of our logarithms, when we expand it, need to have a 4 out in front there. So notice how this 2 only goes to the 7, but the 4 goes to both. All right, so we're going to end up with, actually, I can even go ahead and just distribute that now. I think that would make most sense. So we would end up with log 4, base 4 of 12 to the 4 times 7 to the 8th, right? You multiply the powers. So when we expand this, we get log base 4, or 4 log base 4 of 12 plus 8 log base 4 of 7. All right. So then for number 7, this is on the solving logarithms. All right. First thing we need to do here, if you notice, there's only one log. All right. So I want you to isolate the logs. You're going to subtract 4. All right. You get -8 log 7 2x of -32. And then we're going to divide by -8. So you end up with log base 2 of 2x equals positive 4. All right? So if you look at the two methods, this one has the log on one side, so you're going to want to put this into a power. So I'm going to say 2 to the power of 4 gives me 2x. 2 to the power of 4 is equal to 16, so we get 16 equals 2x. You divide by 2, and you get 8 equals x. Then we need to double check that this works. If we plug an 8 in here, we would get a 16 inside the log, and that keeps the positive power, so we're happy with that. All right, now for the last one. Number 5 on the last page. So what you're going to want to do is you're looking here, and you need to get these guys so that you can use these numbers. All right, we're trying to reduce this. Basically, the numbers that we can use are anything of base 7, base 12, base 8, or base 10, because this is log base 10. So looking at this, I'm like, well, I can change this fraction. I can make it, if I multiply the top and the bottom by 4, I get 8 over 12, which is perfect because those are the two numbers that I have. Then I can expand that, so I get log base 8 minus log base 12. So I get 0.9 minus 1.1, which is going to give us negative 0.2.